Right, welcome to another lesson on Pure 2. This is about chapter 5.3 about areas of segments and sectors. Last time we talked about arc length and radians. This lesson we look into areas of segments. Another formula to remember. So area of sector is segment, sector, and sectors. So sector is part of a circle. Segment is which connects to the center of circle, but segment is this part where we take away triangle. So we can see the sector with area of sector, which I remember is area equals A equals half R square theta that you have to remember. Okay. And the area of segment, which is this part. So you can see area of segment. So segment equals to sector minus the triangle. Okay. Sector we know is half R square theta. Triangle is half AB sine theta, half R squared sine theta. Now, would I recommend you to remember the formula for segment? No, but you would have to remember the segment, the area of sector, okay? Because segment, you can sort of use your, I guess, maths common sense. It's a dangerous word, common sense, to use it. But if it's like a shaded area. How to find shaded area? The bigger area minus the white area. Okay, right. So moving on. Okay. Example. Now, for the following examples, we are going to go through a few examples today. If you feel like you're confident to try them on your own, be my guest, try it and then go to the answer and see if you got it correct. If you got it correct, why wasting time listening to me? You know, example in diagram, the area of the minor sector AOB is 28.9 centimeters squared. Given that AOB equals 0.8 radians, calculate value of R. So we know area of sector is half R squared theta. So the area is 28.9. So 28.9 equals half times radius squared times 0.8. So therefore, we times it by 2 on the left-hand side, divide by 0.8 square root, okay? And then you should get 8.5. So basically making R the subject in here. R equals square root of 28.9 times 2 divided by 0.8, which is 8.5 centimeter. I think around to one decimal place. Doesn't matter, really. Example, next one. A plot of land is in the shape of sector. Here we go. Of radius 55 meters. The length of fencing that is erected along the edge of the plot to enclose the land is 176. Hopefully you do understand this means the perimeter. Okay. Calculate the area of the plot. So we know the perimeter. To find the area, we need to do half R square theta. The question is, we don't have theta. Okay. So, well, how then? Okay, I'll let you think about that. How do we work out theta? Surely we need to use somehow the perimeter. So why don't we set an equation about perimeter? What do we know? Perimeter means AO plus the arc length AB plus OB. Therefore, the arc length, so the AB arc length, we can use this arc length equals to 176 minus 55 times 2, which is 66 centimeters. And that's the arc length. And what do we know about arc length? The formula for arc length from last lesson, R theta. So R theta equals 66. We know the radius 55. 55 times theta equals 66. Theta equals to 1.2. And therefore, the area equals to half R squared, 55 squared times theta, 1.2, which will give you 1815 meter squared. Okay. Moving on. Next one. Example again. Okay. In diagram above on the side, OAB, yep, it's a sector of a circle. We can see we got eyes. Radius 4. The chord is 5. That means AB. The chord AB is 5. Find the area of the shaded segment. Again, pause the video. Try it for go. See if you got it right. I'll tell you the final answer. The final answer is just 3 meters squared. The final answer. Okay, if you've got it right, move on. But if you don't, let's go through. So, what do we know? To find the area of shaded segment, the shaded segment equals to the sector minus the triangle. Okay, the sector. Now, we don't know, the sector is half R squared theta. We don't know theta, so we have to work it out. Well, how can we work it out? Using this triangle, we can use cosine rule. Okay, we can use cosine rule. So first, to use cosine rule to find theta. Okay, so a squared equals b squared plus c squared minus 2 times b times c cos a, which is theta, cos theta. So we want to do some rearranging. So I do 5 squared, 25, 4 squared plus 4 squared, 32, minus 2 times 4 times 4, 8, 32, cos theta. Do some rearranging, make cos theta subject. So cos theta equals 32 minus 25 over 32. So inverse cos theta, make sure you're calculating radians, radians. So inverse cos of 32 minus 25 over 32, which is 1.35 radians. I've got 1.35 radians. Okay, so therefore, this area of sector, so area of sector equals half r squared theta, which is 0.5 times 16 times 1.35. I got 10.8. Okay, and the area of triangle, so area of triangle is half AB sine C. Put in a calculator, make sure you don't forget the sine. Half AB sine 1.35. I got 7.85. 7.80570. So the area of segment, the final answer, is 10.8 minus 7.805. That's roughly around 3 meters squared. Okay. Right. An example. This time, they want you to show that 3 theta minus 4 sine theta equals 0. Slightly trickier. Again, I would suggest you pause the video, have a go at yourself first. These are not, very hard knowledge, but it's just the application part. The best way to learn to apply into maths question is to try to think about yourself first before I give you direction and the cheat. So pause the video, have a go at the question. Whenever you're ready, you can press play. So let's read the question. In diagram, AB is diameter of a circle of radius r. So we're given r and r in here. BOC is theta, okay, radians. Given that the area of AOC is 3 times the area of shaded segment, so we can change this into an equation. So the area of AOC equals 3 times the area of segment. So without me saying anything else, obviously you want to use algebra to replace an area of AOC and the area of segment. So for the whole area of AOC, okay, for the whole area of AOC, it's a triangle. Now what we know is this value here is 180 degree, which is pi minus theta. Okay, so pi minus theta. So the area of AOC, so area of triangle AOC equals half AB sine C, which is half R. Now the radius, that's also radius. Okay, so half R times sine C, pi minus theta. Let me rewrite it neater. Half R squared sine pi minus theta. Okay. Now what about what about sine pi minus theta? Now sine pi minus theta, that's slightly trickier, is actually sine theta. Now let's have a look. Here's the sine graph. Okay. Let's say we've got a 30 degree in here. Okay. The equivalent value on sine would be here. Using symmetry would be 150 degree. So if I do, let's say theta is 30 degree. So 180 degree minus 30 is the equivalent to sine 30. So sine 30 degree is the same as sine 150, which we can rewrite this as sine 180 minus 30. So can you see the relationship here? Sine pi minus theta is the same as sine theta. So therefore, we can now rewrite this as half r squared sine theta. That's the trickiest part of the question. For the segment, area of segment, so area of segment is a sector minus the triangle BOC. So sector is half r squared theta, half r squared theta minus half AB sine C. So if we simplify a little bit. Half r squared theta minus half r squared sine theta. Okay. We're told the area of triangle AOC equals 3 lots of this. So area of AOC, half r squared sine theta equals 3 lots of half r squared theta minus half r squared sine theta. So let me multiply 3 into the bracket. So half r squared sine theta equals to 3 over 2 r squared theta minus 3 over 2 r squared theta. I don't like the over 2. Can you see all the numbers, all the terms have denominator 2. So what if I multiply every term by 2? Then it will go away. So r squared sine theta equals 3r squared theta minus 3r squared sine theta. The question wants me to bring everything to one side, make it equal 0 on the other side. So I will do that. So let me bring everything right left hand side. So minus 3r squared sine theta to left hand side becomes a plus. 1 plus 3 is 4. So and bring this over to minus 4r squared sine theta minus 3r squared theta equals 0. So what's different to the question? The question is no r squared. It's only 3 theta. Oh, okay. Well, we'll divide everything by r squared. So divide everything by r squared. Divide this by r squared. Then it becomes 4 sine theta minus 3 theta equals 0. They put a 3 theta in the front. So if I change the sign of all of them, become 3 theta minus 4 sine theta equals 0. Or think about just moving them on the right side. Same thing. It's quite a tricky question in terms of algebra. Okay, but here we go. Last but not least, okay, exam practice. It's actually slightly, it should be slightly easier than the one that we did before together. So pause the video, have a go at the question. Okay, when you're ready for the answer, you can press play. These are the final answers. 6.3, 28.35, 7.58, and 5.76. Good, right? Well done. Move on. Okay, have a go. Try the challenge question. Okay, they are math questions, so they're not, they're not really simple questions. So, but they're not really the level that you'll be seeing in the exam. So have a good challenge question if you prefer, but if you don't, that's the end of the lesson for you. So let's have a go. Exam practice. Okay, figure 1 shows the sector OAB with center O, radius 9, angle 0.7 rads. Question A, find the length of the arc length. So question A, arc length L equals r theta. So L equals to 9.0.7, which is 6.3. Easy peasy. Part B, find the area of sector OAB. Sector is just asking you to write the formula. So area equals half r squared theta equals half times 6, not 6. Radius is 9 squared times 0.7. Again, just a basic use of the formula, 28.35 centimeters squared. Okay. Question C. The line AC shown in figure 1 is perpendicular to OA, where OBC is a straight line. Find the length of AC. AC. So hopefully you see a right angle triangle. That means you can use SOHCAHTOA or trigonometry. This is the opposite, and that's the adjacent. So therefore, we can use 10. 10, 0.7 equals opposite AC over the adjacent 9. So if we multiply 9 over, so A is equal 9, AC equals 9 times 10, 0.7. Use our mighty calculator. Make sure you calculate in radians, please. Radians, radians. If you go in degrees, you will have got it wrong. And that's 7.58 centimeter. Right? D. The area, the region H is bound between the arc AB and the lines AC and CB. So essentially to find the H, we can use a triangle, the triangle OAC, the whole triangle minus sector. Okay, so area, so H equals area of angle OAC minus area of sector OAB. So we already have the sector OAB from part B. It rhymes. OAB and part B, of course, they rhymes. Part A, find the area of OAC. Well, it's a right angle triangle, so you can do half base times height. So H equals half base, that's the base, that's the height, 9 times 7.58 minus area of OAB, which is 28.35. You put it in calculator, you should get 5.76 centimeters squared. And that's it. All right. Last but not least, again, as I said, if you prefer, if you feel like a challenge, watch the video. It's not simple. If you don't, okay, if you're like, oh, yeah, okay, you can listen to it. But anyway, if you don't feel like it, just finish the video. Finish the video now already. Right, challenge. So that hopefully, you can have tried it. Okay, so let's go through. Okay, if you need a hint, I'll give you a hint. Try to make this a center O and try to draw a few lines on here. That's a hint. Okay. So and then if you feel like I want to try again, then have a go. Okay. Right. If you need more hints, what can I do? Well, we know these are 1. Okay. Try to make this theta over 2. Theta over 2. Okay. I'll let you carry on. I'll let you try it more. But if you're like, oh, I've tried everything, sir, I need to know the answer. Then here we go. Okay. Oh, by the way, the final final answer is theta plus sine theta. That's the answer. Okay. Right. So let's go through if you haven't got it right. Right. So I'll give you the hint already. So bring the center O, and then we've got OQ, OP, OR, and the radius, and they're 1. Okay. Break this into theta over 2. Now, what else we also know is that hopefully you remember your circle theorems. This is the arrowhead. Angle at the center is double the angle circumference. In other words, if this is theta, this is 2 theta. That's the hardest part. That's the hardest part of the question. So then to find the area of the shaded region, okay, we can split in 2 parts. Triangle 1, triangle 2, and sector 3. Okay, so total area equals 1 plus 2 plus 3. Okay, so let's do 1. 1 is a triangle. So triangle means half r square theta. Half AB sine C. So half AB sine C. So now you have to be careful with 1. So let me draw the shape out. We know that's 1. The radius is 1. The radius is 1, and that's theta over 2. But if you want to work out the area of a triangle, what you have to do is you would have to work out the AB sine C. This is your angle C. So how do you work out C? Well, we know from circle theorem that's 2 theta, right? These two are symmetrical. In other words, this angle here will be 360 degree, but we're using radians, so it'll be 2 pi minus 2 theta. 360 minus 2 theta, okay, divided by 2 because they're symmetrical. So that's the same as pi minus theta. That's the same as that one, pi minus theta. So here, pi minus theta. So let's do that. So triangle equals half AB 1 times 1 sine C, which is pi minus theta. If you remember what I said before, sine pi minus theta is the same as sine theta. That's the same as half sine theta. Triangle 2 is the same as 1, which is half sine theta. About 3 is a sector. Sector means half r square theta. Half times radius, 1 squared times theta. The theta is 2 theta. So multiply them all is theta. Therefore, the shaded area equals theta plus half sine theta plus half sine theta. Half times half is 1, so theta plus sine theta. Okay, it's not an easy question, but that's the end of 5.3.